Okay, so today we're going to talk about gas laws, lesson 2, Boyle's law. The big idea here is you need to be able to work problems using the Boyle's law equation. Hopefully you've already done your bell ringer. Today's lesson is really summed up in the picture that's embedded there. Boyle's law is pressure 1 times volume 1 equals pressure 2 times volume 2. So it kind of makes sense. If we have a lot of extra space, the atoms, the molecules are not running into each other as much. There's not as much pressure. If we decrease the volume, we don't have as much space. And so the atoms and molecules are running into each other at a greater incidence. There's more pressure. Kind of like, imagine if our class had to all fit in a closet instead of this room. It'd be a lot of pressure. We would be in each other's space. It would be uncomfortable. It's the same idea with atoms. They're running into each other. It's increasing the pressure. Okay, so in class we watched these videos, really just demonstrations. And then today we're going to switch over and we're going to do some notes and we will work some of these practice problems together. So we want to go ahead to our notebook and we'll take some notes and talk a little bit about Boyle's law. So let's get started with that. So in your notebook, you should have some notes about Boyle's law. So we'll start today's notes about Boyle's law just by labeling it. The unfortunate thing about gas laws is they're just named after the person that came up with them. They don't really give you any indication of what they're using. So that's where you have to really begin to memorize that Boyle's law is pressure and volume. Okay, so when we look at P1 times V1 equals P2 times V2, we need to realize that this is before and after. So we have an initial pressure and an initial volume and a final pressure and a final volume that we're going to be looking at. For the case of Boyle's law, we want to remember that temperature is constant, or it doesn't change. It's always the same. Okay. We want to think about units. When we're thinking about any kind of math problem, we always want to think about the units that we're looking at. So we'll come over here and make a list. Pressure is measured in atmospheres, millimeters of mercury, or kilopascals. So those are just units that tell how much pressure that is in a system. We sometimes will talk about standard pressure. So if we just take a second and think about standard pressure. Standard pressure is 1 atmosphere or 760 millimeters of mercury or 101.3 kilopascals. So anytime you're doing a problem and it asks about standard pressure, these are the numbers or the units that you could use. If your problem already has millimeters of mercury, you're going to pick 760. If your problem is already using atmospheres, you're going to pick 1. Okay, so that's pressure. But what about volume? What is volume measured in? Volume is measured in milliliters or liters or sometimes centimeters cubed. There is no standard volume. Standard volume is just whatever space that it's taking up. Remember, volume is the space that is being taken up. All right. So we already said a lot in these notes, but let's kind of look at our problem here. if I know that the initial pressure and volume has to equal the final pressure and volume, then I know that this is an inverse relationship. And so in an inverse relationship, it means it goes the opposite. So if volume goes up, then pressure goes down. If volume goes down, what does pressure do? Pressure goes up. So we want to keep this in mind as we are doing our problems. Okay. So let's, a couple of things to point out in what we've already said. Boyle's law always has pressure and volume. So if your problem just has pressure and volume, you're going to use this relationship, this equation. Sometimes you will be asked questions that say when the pressure becomes standard pressure, then you're going to use standard pressure. These are the numbers that you would use for standard pressure. All right, let's do a couple of practice problems. And we're going to go back to our lesson. Okay, and our practice problems are right here. So I'll go ahead and open those up. Okay, in the practice problems that you're given, you can see the formula. You can also see another example. We are going to go ahead and do these problems together in our notebook. So we will try to see both the problems and the notebook at the same time. All right, so let's look at number one. Number one, now we know that we're going to be using the Boyle's law equation, so we could go ahead and write it. When I look at any kind of equation, I know that I'm going to need to plug in these numbers. So I like to go ahead and write. I like to go ahead and write what I'm going to need down before I even read the question. So let's go ahead and read the question. A gas occupies 12.3 liters at a pressure of 40.0 millimeters of mercury. What is the volume when the pressure is increased to 60 millimeters of mercury? All right, so my first variable that I'm looking for is a pressure. Gas occupies 12.3 liters at a pressure of 40 millimeters of mercury. So that's my first pressure, 40 millimeters of mercury. I look at that same problem. When it's at 40 milliliters of mercury, it occupies 12.3 liters. Well, it doesn't say volume, but it does say liters, and liters is a unit of volume. So we're going to go ahead and use that number as our volume 1. Okay, and then when I look at the problem again, it says, what is the volume? So if what is before, I know that volume is what I'm looking for. When the pressure is increased to 60 millimeters of mercury. So my pressure to is 60 millimeters of mercury. All right, so a couple of things. I can go back to my relationship here. Okay, pressure was increased, so volume should be decreased. All right, so we look, pressure is increased, so volume should be decreased, but we can't just guess yet. So let's plug in our numbers and find out what our problem really says. So P1 is 40.0 millimeters of mercury times 12.3 liters equals 60.0 millimeters of mercury times volume 2, because we don't know volume 2 yet. So let's see, what can I do? I can go ahead and multiply these two numbers here. And okay, so if I multiply 40 times 12.3, I'm going to get 492. And I need to keep my units. And I haven't done anything to the right side of the equation yet because we just calculated some things. So in order to get the V2 by itself, I need to do the opposite operation. So if I'm multiplying here, then I need to divide to get rid of this number and get the V2 out by itself. Notice cancels out the units, cancels out the number. I'm left with V2 on the right side. But I have to make sure and do the same thing on both sides of the equation. Otherwise, it's not an equation. It's not an equal. Now my units cancel. I'm left with liters for units. And if I divide 492 by 60, I'm going to get 8.2 liters. And that's my V2. If I go back and kind of look at what I had, my V2 is 8.2 liters. And it works because 12.3 was what it was, and it went down just like we predicted right here. 8.2 liters. All right, so find your variables, plug them into the equation, and solve for the one you don't know. Okay, I'm going to go ahead and scoot down in the example problems, and we're going to do number 5 because number 5 is the kind of the next new thing. All right, so let's scroll in the questions to number 5. Number 5 says 500 milliliters of gas is collected. So there's a volume at 745 millimeters of mercury. So that's a pressure. What will the volume be at standard pressure? Okay, we know we're doing Boyle's law. Let's write down the equation. All right, well, I like I tell you all the time, I like to write down all my variables because that lets me know what I'm looking for, what I need, and what I already have. So I start out the first thing in the sentence, 500 milliliters. I know milliliters measures volume, so I'm going to say 500 milliliters is my first volume. This next part of that question there, it says a gas is collected at 745.0 millimeters of mercury. Well, it didn't tell me anything, but I know that unit is a pressure unit. So I know that's my first. That's my first pressure. What would the volume be at standard pressure? Well, that question doesn't give us any other numbers, so how are we going to figure this out? Standard pressure. Remember I told you if we have problems that say standard pressure, we're going to have to use one of these numbers. In that problem, I've got millimeters of mercury already written down. So my standard pressure of millimeters of mercury is 760. So that's what is going to be my pressure 2, 760. That's standard pressure. And then I just plug it in just like I did before. So we'll go ahead and go through that and show you what we come up with. Okay. So P1 is 745.0 millimeters of mercury times 500, which is V1 milliliters, equals pressure 2 is 760 millimeters of mercury times V2. You can't see that anymore. So then if we do 745 times 500, we get this big number. 372,500. We got to keep our units because we haven't lost them yet. We haven't canceled them or anything yet. Now, you might be mathematicians out there, and you might know that you can just put that 760 under there all in one fell swoop. But I like to show all my steps. So I'm going to divide by 760 millimeters of mercury. And that's going to cancel. I'm left with V2. I have to do the same operations on both sides of the equation. Otherwise, it is not an equation. Okay, so that millimeters of mercury, the unit cancels. I'm left with milliliters. And I need to divide 372,500 by 760. And I come up with 490.1. Now, there's a whole bunch of other decimal places, but I have 4 significant digits, and I have 4 significant digits. So my answer should also have 4. That's how I know where to round off to. All right. So don't let standard pressure throw you off. That's what we had in this problem. We just had to go back and find what our standard pressure was that matched. All right. So what I'd like for you to do is I'd like for you to finish those problems. So you should do 2, 3, 4, and we did 5 together, and then you're going to do 6, 7, and 8 on your own. All right.